Hi guys, welcome again to my YouTube channel. Guys, today we look at this question on Fourier series. And I read the question, given the function fx is equals to, open the bracket, -6 is between -pi and 0, and 6 is between 0 and pi, and the period is 2 pi, that is from -pi to pi. Sketch the graph for 2 periods and determine the Fourier series. So guys, we draw that graph. Already have made a structure for that, which is here. And so the first one is -6 from -pi. So this -6 and -pi. So that is our first point. Straight line where it meets there. That is our first point. And then you can look at this 0 from -pi to 0. So the next point is here. So we join those two dots, and I can do that. After joining those two dots, we go now to 6, where we are told 6 is from 0 to pi. That is 6, that is at that point, which is 0, and 6 is here. Then pi is also 6, so at that point. And so guys, we also join that point. So that point is going to be like that. And so guys, we can join those 2 points like that. And therefore, our graph is then going to go, because remember this is a complete period. So if it moves like that, it will now go back again like that. Just as you can see, it's now going to go like this. So guys, this is what I have added, because this one is 1, then another one will start from here and move just like this. And so we connect there, guys. And so guys, these are the 2 periods. One of the period is from there to there. Another period is from here to here. So those are our period, guys. From there, the questions is determine the Fourier series. And so guys, let me write the equations that we need to use for that. So guys, here is the complete series that we are supposed to use. And so guys, the first thing we look at is this equation, this graph. Guys, we want to see whether this graph is even or odd. And the way we can be able to find out is the line of symmetry. The first thing is not symmetrical along the y-axis, because if you look at this side, you have -6 and here we have 6. For odd functions, we know that they are odd by this. It's supposed to be negative fx equals to f negative x. So if they are equal, then guys, this becomes odd. We can now place, let's say we place pi for that. If we place pi, guys, we are going to have -6. If then we come and place pi, now this one becomes -pi. This one will also give us -6. And so guys, this one becomes an odd function. And so we come and now, because of that, these terms are going to disappear. These terms are no longer going to be there. These ones are going to be 0. And this is also going to be 0. So guys, we just work with one term. And we are given the term as shown, and we have the Bn, which we are going to first of all work it out. So guys, let's start. So the Bn is going to be equal to 2 all over pi integral from 0 to pi, that is from this point to that point. And because this is half of the period, we multiply by 2. That's why we have multiplied by 2 there. So we come and find out, we use this function, the first one, we can use the first one, that is 6. So we are going to put 6 here as our function, and then we have sine n x dx, like that. So guys, now we do that, we are going to get 12 over pi, 2 all over pi. If we integrate that, guys, we are going to have 6 there, which is a constant. Then this one comes to cos nx all over n, like that. This now is from 0 to pi. From there, guys, we come and now replace for that. So we are going to have, first of all, we can put this one aside. But before that, guys, we also have not factored the negative, because this one will have a negative here. That will give us a negative, because the integration of sine is negative cos. So this one will be negative 12 all over pi n, can factor out pi n. Then here, guys, we shall have, this is negative cos n pi minus cos n 0, which is cos 0, like that. So guys, when we come now to that, we shall have negative 12 all over pi n. We check for cos 0, we are going to have 1. So this is cos n pi minus 1. So guys, we are going to have that. With that, guys, we can come and now look at n and see. When you put n is equals to 1, guys, we can now put this one as, before we do that, we can come and say, because of this negative, this one will interchange the position so that we can remove this negative. So we'll have 12 all over pi n. Then we have 1 minus cos n pi, like that. Guys, now we check for n. When n is, let's say when n is even number, that is to say cos 2 pi, or others can be cos 4 pi. Let's see what we get when we put that, guys. So this one is going to give us cos of 180. Cos 180 gives us negative 1. If we go to cos 180 times 4, which is 720, cos 720 gives us 1. Let's look at it again. We said cos 360, that is not 180 but 360. Cos 360 gives us 1, and cos 720 also gives us 1. So this is 1, and here we have 1 guys. And so, guys, we are going to have, this is now going to be, because this is bn, Bn then, guys, is going to be 0 for even numbers. So let's now come for the odd numbers. This one is going to be for odd when n is odd number, that is cos pi and maybe cos 3 pi. This one is 1 pi and 3 pi. Cos pi, that is cos 180, gives us -1. Cos 3 pi, that is cos 540, gives us -1. So guys, here we have -1, -1. And therefore, guys, we are going to have this equation Bn is therefore going to be equal to 1 minus -1 will give us, for this, will give us 2. So this is going to be now be 24 all over pi n. So guys, this is now going to be our Bn. But fx is equals to summation n equals to 1 and infinity there, Bn sine nx, like that. And this one, remember, it's only for odd function, so we have to take care of that. So this one is now, we can say, for odd numbers, that is equals to, that is for n, only for odd numbers, guys. And so guys, from there, so guys, to save on time, I have done the rest and now I take you through. So guys, we look at it this way. We have already found the Bn is supposed to be 12 all over pi over n. So that is 24 all over pi over n, which is this. I've already fixed it there from what we had found earlier, guys. And then after that, we come and now we can factor it out so that now it comes outside here, guys. After it is there, it's factored out, what we shall have now, guys, is to form our series. And the way we can form our series is by, when now forming our series, guys, we take note that n is supposed to be odd, where n is odd numbers, as we have found out. So now, guys, when we come here, this is now becomes our series here. This is our series for that. And now, guys, from there, we can even make it much better by doing like this, so that now, guys, we represent as odd function, because if you put 1 here, it will be 1 times 2, 2 minus 1, 1. If you put 2, 2 times 2, 4 minus 1, 3. So this one represents odd function. And so therefore, when you are presenting the series, is supposed to be like that. But now, just to expand it a little bit more, we can do it like this. We can say 24 over pi, then we can put 1. If we put 1 here, this is going to be 1. And so therefore, here we shall have 1 like that. And n is also 1, so we shall have the first term as that. The second term, of course, is multiplied by 24 over pi. The second term will be, you put 2 there, 4 minus 1 is 3. So we have 24 over pi and 3, and then this one is going to be 3, like this. So guys, this is our terms, and thank you for listening to me. Bye bye.